Today I'll show you everything you need to know about the Singleton Design Pattern. It is one of the 23 design patterns. It's a creational design pattern and it's super easy to remember. So what is the problem we want to solve with Singleton Pattern? Consider the following example. Let's create a class client. This application is going to create a new client and then execute a method show me all products. The method show me all products is going to retrieve the products from a database. So we need a database connection class. Let's create it. Create class database connection in the same package. This class will have only one method called retrieve all products. Let's execute it. And now let's implement it. For this example, the method is just going to print show all products from the database. Let's run this example. Okay, seems to work. Show all products from the DB is printed on the console. Now I'll add one more client, client 2, and run it again. Okay, good. One more thing, I would like to see the database connection instance which is used. So I'm going to print it. And let's run the application again. You can see our clients are using different database connection instances. But what if we want to have only one database connection instance in our application and all clients to reuse it? In order to achieve this, we must make the database connection class Singleton. Generally, there are three reasons why you want to use the Singleton design pattern. Number one, there is only one instance of a certain class that is going to be created. Number two, you control the lifecycle of the object so you can make the initialization lazy. It's not mandatory, but it is a common practice. And number three, another common practice is to make the singleton thread safe. And in the real world, we usually see it in logging, driver objects, or database connections. One example in Java itself is the Java runtime class. Let's go back to our application and make the database connection class Singleton. Take a look at the class diagram for the Singleton pattern. There is a private static field. This is the Singleton instance. There is a getInstance method, so if anybody needs a database connection, they will have to use this method. This method is supposed to check if the instance is not initialized to initialize it and otherwise to return it. And finally, there is a private constructor because we don't want anyone to be able to create new instances of database connection. It's not unusual to have slow operations in initialization, and it could be the reason why you want to have only a single instance. Now we have to change our client. Instead of calling the constructor, it should call the getInstance method. And let's run the application. Now our two clients are using the same database connection instance. Let's take one step further and make this singleton thread safe. One way to do it is to make the getInstance method synchronized. But this is not a good approach because if there are many threads calling the getInstance method, they will have to wait each other and this will lead to performance issues. So I will show you how to avoid this. We're going to synchronize only the initialization part of getInstance method. However, this is not enough because if there are multiple threads waiting on line 12, one of them will initialize the instance and return it. And after that, the next thread will initialize the instance again and return different instance. So we need additional check if the instance was already initialized. This leads to a little code duplication, but it's necessary, because this way we can have many threads calling the getInstance method and not locking each other. Only at the moment when the instance is not initialized, there is a locking between the threads. There is one more thing we need to do in order to make this solution perfect. We should make the instance volatile. Volatile solves a visibility issue. If you declare one variable as volatile, then its value will be visible to other threads immediately. Volatile is important here because of the internals of the JVM on bytecode level. The initialization statement is on bytecode level actually something like that. It's kind of two statements. So if instance is volatile, the JVM guarantees that 1 and 2 are executed as an atomic operation from the point of view of other threads. If you don't use volatile, it might be that other threads can actually see the reference of singleton before the constructor has been called, and this way some threads might see an incomplete object. So this is now a perfect solution, and it is our first implementation of Singleton. The second implementation that I want to show you is similar. I'm going to copy the database connection class. I will name it database connection inner class because I'm going to use inner class. Instead of having a field in this class, I will define an inner static class and declare the singleton instance inside this inner class. Maybe you have seen this technique, it's called initialization on demand holder. In the getInstance method, just return the lazy holder instance. We don't need to perform any additional checks or synchronizations. This technique relies on the initialization phase within the JVM, which is specified by the Java language specification. So when the class, I mean the database connection inner class, is loaded by the JVM, the class goes through initialization. And since it does not have any static variables to initialize, the initialization completes. The inner static class lazyholder is not initialized until the JVM determines that it must be executed. And since the class initialization phase is guaranteed by the Java language specification to be sequential, no further synchronization is required in the getInstance method. And this is the second implementation of Singleton Design Pattern. And I think it looks better than the first one. It has the same features. It's lazy initialized and it's thread safe. Let's test our second implementation. Changing the client to use the inner class implementation and running the application. It looks good. Okay. And finally, I'm going to show you my favorite implementation of Singleton in Java. It's using Java enums. I'm going to create a new class, database connection enum. I will declare one instance and one method that is going to do whatever we want our singleton to do. In our example, this is the retrieve all products method. That's it. That's all you have to do. I really like this implementation. I think this is the most elegant solution in Java because out of the box you get thread safety and lazy initialization. If you don't know this, enums are initialized when used for the first time and you don't have to deal with synchronization issues. I would say this is the recommended way to do singletons in Java, not to mention that you can implement it in like 5 seconds. Let's test this implementation. Going back to the client, and we have to replace the getInstance method with the instance of the enum. And let's run the application. And again, we should see that client 1 and client 2 are using the same instance. Now you know how to implement Singleton, but I encourage you to think twice before you use it. You will often hear people talk about Singleton being an anti-pattern, and there's a reason for this. Singleton is like a global variable in your application, and this is not a good sign in object-oriented programming. It makes the code more complex and violates the single responsibility principle. Also, it's hard to test Singleton. Hope you enjoyed this video, and if you learned something today, please subscribe to the channel.